Hello, welcome back to Cracking the Cryptic. Now the old throat's getting worse, but nonetheless it's time for another gas attack. Yeah, I'm going to have a go at 5 genuinely approachable Sudoku puzzles from the Discord server's daily Sudoku channel, where Clover, Sam Cappleman-Lynes and Philip Newman prepare genuinely approachable Sudoku puzzles to kind of demonstrate some of the basic types and others, and I try and go through all of those puzzles, round up 5 at a go a few days later, and haven't done some for a while. I've had a very hard puzzle or two in the interim, so I'm looking forward to hopefully being able to dash at these. Now, our Patreon reward content for the month is up, and we have had correct answers in, and incorrect answers actually. So do see if you can figure out, if you're a Patreon, see if you can figure out who is the winner of our 3-way duel, and send us the answer if you want. Now, that is on Patreon. We've mentioned Discord. We've got all our apps, wonderful Christmas presents they make. We've got so much going on with Sven's Sudoku Pad as well, which is now on Steam and therefore available on PCs. And what else? Merchandise, a go-go, loads of that, and that makes great Christmas presents too. So, all of that said, let's run through the rules of these 5 puzzles, and then I will attempt them as fast as I can. So, first of all, from November the 9th, we have Symmetric Unequal by Clover. So normal Sudoku rules apply. Digits that are opposite each other by rotational symmetry around the center of the grid may not be equal. So this number won't be the same as that one. That's kind of how the rule works because of the rotational symmetry. So that number won't be the same as that. This has a symmetric partner there, and they always have to be different. So that's the only extra constraint. You get as many givens as for a classic, pretty much. And that's how it works. Now, the next one, Sam has given us another Symmetric Unequal. Yeah, same rules, just run through them. So that won't be that digit in this one. Yeah, obviously Sam and Clover, I think they did this last time as well. They are sometimes planning the same type of puzzle between them. Philip, not so. This is a German whisper puzzle called Out with a Foot. Along green lines, digits must differ by at least 5. So neighbouring digits on the green line have to have a difference of at least 5. So those two could be 1 and 6, but could not be 1 and 5, for instance. Those two will differ by at least 5, and those two got... Oh, I see, it is the shape of a foot here. That's quite funny. Okay, I'm so slow, I hadn't spotted that. Very clever. Then we, only one Philip perhaps this month. That's handy for me. Then we go on to an LK killer. So this has got little killer clues and killer clues. So within cages, digits can't repeat, and the cage must sum to the small number given. And clues outside the grid show the sum of the indicated diagonal. This time they can include repeats if the other rules allow it. And that's Clover's second puzzle for this session. And Sam's second puzzle is XV pairs. So any 2 cells joined by an X, think Roman numerals, they have to add up to 10. Any 2 cells joined by a V have to add up to 5. There's no negative constraint. Sam may not have given us all of the X's and V's. So what I'm going to try and remember to do is restart my clock for each puzzle so that I know how I'm doing. I'll also put a timer on that so you can see how I'm doing. And let's get cracking. Right, so 5, 4, 3, 2, 1. So that's a naked 9 with a 6 there as a result. Oh, in fact, I can do 7 and 8 in that row. So that row's all done. This is naked as well. Oh, lots of nudity in the middle rows. That's a 1. That's a 4. Yeah, these rows are fully done. I might as well mark off the triples that remain and take out the candidates that are pointing vertically. Now, I haven't even thought about the rule yet in this puzzle, which doesn't really matter across those, but let's go vertically. This is naked as well. That's a 7. The column is less helpful after that. This is 3 or 9, but now I can use the rule. There's a 9 up there, so we can put in a 3. This is 5 or 9. The rule doesn't affect that. This is 1 or 9. Obviously, the rule doesn't affect that. This is 1 or 9. Ah, it can't be a 5. Yes, okay, so ordinary Sudoku could have given me a 5 there. Now, this has become a 9, so that triple's done. If I marked it correctly, 8 and 6 in those positions. The rule doesn't seem to affect that. That's naked. There's a lot of cells that one can just get by Sudoku here. So you don't really want to get too hung up on the rule. 4s won't disambiguate. Oh, 6 and 6. 6 is here somewhere in the box. So this is a 2-8 pair. Yeah, top row's all done if I'm in the right mode. There we go. 2, 8, 6. Now this is 2 or 8. And this is 2, 6 or 2 or 6. 3 is in one of these cells. The rule doesn't affect that. Yeah, I'm going to probably have to find somewhere else that is affected by the rule. That, for instance, can't be a 3, so it looks like it's 1 or 7 to me. 3, 7, 6, 4. That is 1 or 9. 8, 3, 7, 6, 4. 1, 2 or 9. The trouble is most of the cells I don't have filled in the top half correspond to the ones I don't have filled in the bottom half. These are from 6, 8 and 9. That's a triple, is it? Yes. So this is a 1-7 pair. That's giving me a 1-7 pair here. It's giving me a 9-5 pair up here. These are from 2, 6 or 8. Now, what about this 1-7 pair? That stops that being a 1. This is 2 or 3. That's totally irrelevant up there. 2, 8 or 9, that can't have any extra benefit from the rule because it's in column 5. 5, 7, 8. I don't know. There's probably some way I'm not able to use the rule that I should be. That is 1 or 8. That's 1, 3 or 8. I mean, I suppose 8 is common to both sets of possibilities, but it doesn't seem to be very helpful. Maybe I just need to find what's missing from this row. 3 has to be in one of those 2 cells based on what I've... Oh, 3 has to be here if it can't be there. Yes, that was important. That's how the rule is helping. Right, and 3's in one of those 2 cells, which isn't that useful. It's forming an X-wing there. That can't be 2 anymore. We've got 1, 5. Ah, that's 1 or 5, so we can place 7. And that is in the pair in the row. So we get 1 and 7. Does that 1 do anything? No. 7, 5. That is 3, 6 or 9. 5 must be there. So that does fix this cell. Oh, that is helpful actually. We get a 9. That's going to finish off the rest of the column. And box 5, that can't be a 2. We've got 1, 8 and 9 to place there. This is now a 7, 6 pair which can be filled in. That's not a 6. 6, 1, that can't be a 1. That's become a 5. 2, 3 and 8. 2 or 3 there. Probably going to still need one more application. Oh no, that's become 3. Right. So that fixes that as 3. That is 2, 8 1, 5, which I could probably have put in before, 6 and 2 in the final column, 8, 7, this is where 1 goes, 4 and 8 are done, 6, 4 and 9, yes, I can go up from the bottom doing those, 9, 6, 4, this becomes 1. Now, I still haven't quite finished, but 6 is ruled out of that cell by the rule, so it goes in there, and that is going to let me finish off. Actually, I could probably have done that a different way. 9, 6, and up here 8 and 2. So 6¼ minutes for that one. Okay, that's not too bad. And we will go on to the next puzzle. And this is Sam's version of the same rules set. So let's give this a try. We can restart the clock and get going. Okay, so a 4 by Sudoku in there. 7 there. 6 3s in one of those cells. Oh, we know which one. Thank you, Sam. So 1 in one of those. That's not affected by the rule. That can't be 2, so it's 5 or 9 down here. 6, 3, 9, 7, 4. That's 5 or 8. Now, if I'm going to focus in the top right, I'm going to get nothing on the rule from the other end. That's 7 or 9. 7, 8 or 9. Now, this can't be 6 by the rule. So, in fact, we do know where 6 goes in the row as a result. Thanks to the rule, that's going to give us a 6 here and 6 here. And that's a fair number of 6s to be going on with. 7 can't be there and also can't be there by the rule, I think. Yeah. So 7's in one of those two. 3, 4, 6, 7 up here. So 9's in one of those. 5's in one of those. This central one is 1 or 8. 3, I've just noticed, is basically given in row 2 and 2 in row 3 now. So in fact that's 5. That's not 3, 5, 4, 6, 2, 7. That's 9. Part of a 1, 8 pair here. 7, 4 pair here. And we know that 7 has to be in one of those two cells. Yes. So that is 8 or 9 as well. We can place 5. Looking down this column, that's become 5, 2, 3. 1 and 8. This must be a right-in. It's a 9, 2, 8 and 5 going down here. This can't be 5 by the rule, and this can't be 5 by Sudoku. So 5's here. 8, 6, 2. Oh no, that's no good. This one's used the rule again. Sam's very helpful with his digit placement. The rule is constantly coming into use here. 1, 4, 9 there. Neither of those can be 4 by the rule again. So we get 4. That's a naked single 9 now. 5 or 7 here. 2, 3, 4, 9, 6. 1 or 8 here. 8, 9, 6. 4 has only got one place in the central box. So therefore 5 only has one place. Now that's 2 or 3. 5, 5. One of those is a 5. 3. That is 2 or 7. Can't be 2 because that would put a 2 here in this box and they would then see each other. That's quite interesting. Hadn't used that kind of logic before. Maybe it would have helped me before. So 1's definitely there somewhere. That's 3. Oh no, that is a 9 because it's seeing a 3 as its symmetrical partner. Wow, again, the rule is just constantly coming in and helping. One of those is a 9, and that's not a problem with the opposite. 9, 4, 6, 5. That is 1 or 7. 2, 3, and 6 to place here. Oh, that can't be 6 by the rule. That can't be 3. And this can be either 5. That, look at that. That's a weird naked single. If we use the rule, again, 3 there. That makes this 2 and 6 with a 3 there. That makes this 2. 6 and 4 can go in the row. 9 I can place. So looking down the first column, 1 or 8 there, so we know where 7 goes. That gives us 7 there. 1 in the central box, that's not a 1. That's now given. 8 and 5, we can place 5 and 6 in row 7. 2 there. 9. 1, 3 pair. That's an 8. 1, 8. Yeah, this is finishing off now. 4 and what have we got? We can do 2 and 8. What's this row? 3 and 7. They're just ordinary Sudoku. Hurrah! And 3 and 1. That's very neatly done, but well, 5 minutes 34. It felt like it was a bit quicker, oddly, on that one, but very neatly done puzzle. Well, as Clover's was. I mean, these are always just good fun. So next up is the German Whispers by Philip, out with a foot. So let's see how we go. Let's get cracking. Now, 5 can never be on a line. So 5 in that column's in one of those. 5 in the central box is in one of those. So we now know that's a 5 and that one. And this in column 3. I haven't made a mistake. Don't think so there. Decent start. 5 must be in one of those two, so we can place it up here as well. Now 6 has to be next to 1. So we get a 1 in one of those cells. I was wondering about 4 and 6 down here. None of those cells can contain 1 because they would all have 2 neighbours that would have to be the same but that see each other. That could be a 6, but otherwise 4 and 6, oh, they could be there. I don't think that was a sensible thing to look at. Okay, high, low, let's do that. Sorry, I hadn't even thought of that. I can alternate high and low. I could have done that from the 3 that was given if I had bothered thinking about it. So those ones are all low. We'll make them blue. Everything else is high. So this is 1 or 4, and it can't be 4 because it would be surrounded by 2 9s. This is 1 or 2, as is this and that. This is, yeah, that can be a 4. So 2, 3, and 4. So can this. They can't both be, obviously. Now that can't be a 4, and it also can't be a 1. Same with this. So that's a 2, 3 pair. This one is 1 or 3. This, as I said, can be, well, it could have been a 4 in theory, but it can't be in practice. That one could be. So what about the ends that can't be 6s? So there and there, that can't, oh, in fact, it's seeing a 3, isn't it? So 3 has to be surrounded by 8 and 9. That's the sensible way to do that. 7 and 4 here. So we get a 7 there. That must be surrounded by 2 and 1. We know the order. That 2 gives us a 3 here, which must be surrounded by 8 and 9. This, well, they can't both be, oh, that's become a 2. So this is a 3, 4 pair. That must be a 9 in between them. So then we get 8 there, 9 there. That can't be 6, so it must be 8. 4 and 6 left to go in the column. Sorry, I am going to pause to blow my... Better remember to deduct a few seconds from what I see on my time at the end. Oh, now I've lost power of entry numbers. There we go. 2, 4, 7, 5, 1. So we've got 3, 9, 8 and 6 to place here. This is high, but it could be 6. Oh, so 3 definitely goes here. These are all high, 6, 8 and 9. So these two are both low. And they're now going to have to be a 3 or 4 there and a 2 here. That means neither of these can be a 6. So in fact this is a 6 with a 1 there and a 2 at the bottom of the line. 7 and 6 can be filled in column 3 thanks to the givens. That's now become a 4. 6 there. 6, 1, 7 is the high digit. 9 in this row is there. Then we have a 5, 8 pair. That must be a 7. That's an 8. So that's all. Oh, look, 8 and 9 were done earlier. So that's almost all of the German whisper stuff complete. This is high, and it's not 6, 7, or 8. So it is 9. 6, 3, 5. So we can place 8 and a 4, 7 pair. 6, 9 down here. 3, 4, 5 triple. That one can't be a 4. Oh, this has become 2 and 1. That's been resolved. So in fact 1 is there and 2 is there in row 8. 7 seems to be here and 6 here. 7 fixes this 4, 7 pair. We've got a 1, 2 that can be filled in. 6, that is a naked single. 3, which fixes the last blue cell there. We've got a 3, 2 and a 9, 4, and I think we're now just filling in, not quite actually down here. 3, 7. If I just take it in the right order, we should be okay. That now has to be a 7. So 9, 3, 5, 6 still to go there. 3, 5, 6. That's a 5, 6, 3. Still don't know about those. Right, I can do 6, 9, flip across and do 6, 5, flip back and do 4, 5, 4, 8 in the bottom row, and 5, 8 in row 6. There we go. 6 minutes and 4 seconds. Now, I often miss the 2-hat time on Philip's puzzles, but I think, I'd hope that is it for this one. Now, we'll go on to Clover's LK Killer next and reset the clock. Here we go. Let's get cracking on this. So we've got a 6 diagonal is 1, 2, 3. They're all in the same box. That's 9, 8, 7, and I can see that one's the 9. 30 is a bigger number, so is 18. But maybe I can use the cages. 36, it excludes 2 that make 9, so that's 4, 5. So we've got 7, 6, 8, and 9 there. These lot add up to 10, so that's a 1, 2 pair on the inside, 3 and 4 on the outside. Now this cage adds up to 39. Oh, this one adds up to 42, so it's missing a 2 and a 1. So 3, 4, 5, 6 must be the diagonal, and 7, 8, 9 must be the other diagonal, the unmarked diagonal. Those can't be 6. And this one is missing a total of 6. Not quite sure I know what to do with that. This box cage adds up to 15, so it's 1, 2, 3, 4, 5. How do I dispose those? That's 4 or 5. Oh yes, I can do the 5 and 4 in this box. Not sure. I think I'm missing something there. I've got oh, that can't be 3. So it's a 1, 2, 5 triple in this row. In fact, that's a 5. Now I've got a 1, 2, 3 triple. Don't know here. That is a 7, 4 pair. But the 35 cage is 9, 8, 7, 6, 5. I should have thought about that. That's where 9 goes. That's where 5 goes, and a 6, 8 pair. 7 in row 4 must be there. That's become a 7, yes. 8 there. Lots of 1, 2 pairs all over the place at the top of the grid. Right, and they are disambiguated by a 2 that I hadn't scanned down to see. That's a 6. So that's the top 3 rows complete, actually. We get a 7. That can't be outside the cage. Sorry, that's nonsense. The cage has to contain a 7. So it's got to be there. That's the way to look at it. And then I stop finding anything useful to look at. This can't be 5. That can't be 4. This one can't be 3 or 5. 1 or 4 there. 1. Oh no, this is a 1, 3 pair now. So that is 4 or 6. So 1 is actually in down here. That's part of a 3, 5 pair. We get the 4 in the cage and the 6 and the 3 and the 5. So that cage is done. Now, it doesn't have to be a 5 in this cage, I don't think. In fact, I can now see there is no 1 in it, so there is no 5 in it. Those are the digits missing. And therefore, 5 in this column is here and here in the box. So 7 is in, 1, 5 are missing. The others are 2, 3, 4, 6, 8, 9. 9 has to be, I know, in one of those 2 positions. Bother. That's 3 or 6. 2, 9 pair. Yeah, okay, and that wasn't the profitable way of looking at this. Finish off that box. This cell is done by the row. That is 4 or 8. 3, 5, 7. I can't remember what I said was in this, but 1, 5 are missing. 1, 5, 7. Oh, that's also seeing 6 and 8, so that's 2 or 3. That's 4 or 6. And whatever that is, no, that's nonsense. Oh, I really got slowed down. That's a 7. It's the last one in the grid. Can I do 2 in this column? No. That is 2 or 8. That's 3 or 9. Oh, I'm struggling here. No, it's this. This has to add up to 30. Why do I forget that? It's got to be 6, 8, 7, 9. Oh my goodness. Absolute forgetfulness. Right, sincere apologies for that dithering around. That's a 2, 8 there, 9 and 1, 4, 6 pairs still to resolve. This has become a 3, 6, 2, 8, 3, 5, 7, 1, 4, 9. We've got 1, 8, 6 triple in the middle. 2, 3, 9 here goes 3, 2, 9. 8 and 6 and 6 and 4. Oh, hang on. 3 and 1 also. There we go. So 6 minutes 20, and I wasted about a minute by just forgetting I had a diagonal clue that I wasn't using. Not too bad though. Nice puzzle again, as always, by Clover. Really approachable. I mean, you've got so many ways into it. It's very well done, and it makes you think about the combinations involved in 3 and 5 cells that have to be different, and 7. Right, and then we will go on to one more. I'm going to take a little blowing break, and we're back. And this is an XV pairs Sudoku, restarting the clock. Here we go. So all of these are the numbers 1, 2, 3, 4. I'm going to mark them in blue just to save time. They're not all of the numbers 1, 2, 3, 4, but there are a lot of them. So that's a 1, 4 pair next to 6 or 9 there. That means this is a 2 with a 3 next to it. That means this is a 1, 4 pair with 6 or 9 there. That means this is a 3 with a 2 next to it. So that's a start. That's one pair and that's the other pair. So these must be from one V pair and one from the other. So one of them is a 2 and there's a 3 in one of those cells. And wherever they're looking across at a 1, 4 pair. Same here, one of these is a 3 looking at a 2 in one of those cells. Therefore one of these two is a 3. I suspect this isn't a sensible way to go about it. This is the other. Doesn't have 7 or 8 in it, so it's either 1, 4, 1, 9 or 6, 4. Same is true down here. Two must be in one of those cells, so I might as well keep pencil marking that. Oh, I'm just not seeing what to do here. There's no negative constraint. These are all 5, 6, 7, 8, 9. Sorry, I'm going to take another break. My nose is not behaving itself at the moment. So, what do I need to see? 2, 8, 3. Right, if that wasn't 3, it would be 1 or 4, and that would mean that this was a full set of 1, 4, 6, 9. That's all right. Oh, come on, Mark. Think about it. What are we missing here? That is a full set of 1, 4, 6, 9. So these are from 5, 7, and 8. Same up here. Don't see how that helps at all. Or marking these as 5, 6, 7, 8, or these as 5, 6, 7, 9. But I'm doing it just in case it leads me to see something. Oh, this can't be 9, 1 or 2, 8. So that is a 3 or a 4. That's a 1 or a 2. That's a 3 or a 4. I suppose this pair can't be 2, 8 or 3, 7 either. So this is the low digit is 1 or 4. Why is that different from here? Because 2, 9 is a very different pair from 3, 8. Okay, so 4 or 1 there. So that's a 1, 4 pair. Ah, so now I know where 3 and 2 go. Why has that taken me so long to see? Don't know. 1, 4, 4, 6, 3 and 2. We know which way round they go, and that's 1 or 4. So that gets me a few digits. That's a 7 and that's an 8. This one is a 9, right, because it can't be a 6. So that gets me all of those centrally ones. That's a 6 and that's a 9. We've got a 5 there and a 7, 8 pair around. 1 and 4 can be done on the flanks. 8 must be there. This is part of a 5, 7 pair. So that's a 6, and this is part of a 5, 7 pair. Now, this can't be 6 or 9. Oh, look, we've got a 4 in the box. So 1, 9 there. We've got a 1 in this box, so we can put in 4, 6. We get another 6 here. 7 in this column must be in the middle box. This is part of a 5, 8 pair. 2 and 9 can get written in. 5 and 7 down here. And that is a 3. So we reduced all of boxes 2, 4, 6, 8 to a single pair remaining. That can't be 8. So 8 is in one of those two cells and not there. This is a 9, 1, 4, yes, and this one's been done. This is 6, 4, 1. So that's all the clues I've been given finished. The rest is Sudoku. Ooh. Don't feel like I've got enough. 2, I suppose, has to be there. How many 2s have I got? Almost all of them. We can write in the last 2. How are we doing on 3s? Yeah, not bad. We can do the last 2 3s similarly. 4s? Oh yeah, okay. Well, this is the way to approach it, is to find the missing small numbers. There's 2 of each due to the symmetry. Let's have a look at 5s. Oh, useless. Right, let's do 6s. Ah, so 6 has to be in one of those 2 cells. And therefore 6 is there. And down here, 6 again in one of those 2 cells. Now, that can't be 6. That's a 5, 7 pair. That's where 8 goes, therefore. 8, 3, 6, 2, 1, 4, 9 must be there, and a 5, 7 pair remaining. This is 5, 2, and 6. So the others are a 7, 8 pair, which I can't disambiguate either. That is 5 or 7. So the 8 in this column is there. That must be helpful. The 8 in this column is at the top. That does all these pairs at the top. 9, 7, 2. So we get 5 and 7. That becomes an 8. This must be a 9. In fact, that's been resolved. 6 and 9. That is a 5. 7, 5, 7, and just 2 digits. There we go. That's, yeah, I got a bit stuck. I think my performance has been gradually getting worse as we've gone through these puzzles, so I may have started shedding hats, but lovely to get through them again, as always, and really good puzzles. I mean, I have enjoyed all 5 of those completely. I would like to have been a bit smarter on this one, to be honest. I think I did the right thing with the highlighting and then completely failed to use it. Why I couldn't see that that was limiting this pair usefully. I think that's what got me going, or maybe that one. I don't know. Anyway, we got there in the end. Thank you for watching, and enjoy your gas and all your other Sudoku. Hope to see you again tomorrow on the channel. Hope I'm feeling better by then. Bye for now.